really good.
And the facility that we have to practice our own table tennis game.
The coaches are really friendly, they are really experienced, and
it's a place where you can play without any selfishness.
Majority of students end up in many colleges across the country, and quality varies a lot from college to college. What should a premier educational institute like the IIT Madras be doing? And NPTEL is an answer to that.
NPTEL is an online courses or a MOOCs platform. We can call it a revolution in online education.
Today, nptel.ac.in, our website, is one of the largest repositories of engineering content in the world.
The type of students that we are able to reach is a fairly broad spectrum which goes into this idea of lifelong learning.
NPTEL with the local chapters is actually a very collaborative environment in which we want to cooperate and work with the colleges rather than being a competition for them.
Wherever you are, whoever you are, if you're interested, you can learn.
In 1977, department has been formed as the Ocean Engineering Center within the campus of Indian Institute of Technology, Madras. We are multidisciplinary in nature with civil, mechanical, added flavor from electronics. We work in unison for the success of any development happening in the ocean environment. We are the technical arm for the Ministry of Shipping for all port-related activities. Another major program at present what we are carrying out is climate change impacts on coastal infrastructure and its adaptation strategies. We would be very happy to deliver a design guidelines for climate change influence on the coast. In the area of refractory high entropy alloys. So these alloys can sustain temperatures way beyond 1000 degrees Celsius. Their applications are high temperature turbines, gas turbines, rocket nozzle tips, etc. IIT Madras has world's first remotely operable local electron atom probe. This is the only place in the country where an academic institution like IIT Madras has this facility.
The reason I chose IIT Madras for my research work are the availability of the best faculty in India and the state-of-art lab facilities available here. I am working in developing a metamaterial which is light and cheap, which can be used in aerospace or maybe in spacecrafts.
With the help of our resource and facilities, we have developed our own cost-effective microcity system which has been used for so many applications. So this detector is patented and the entire system is also patented, and we got 2 funded projects from the government also. So with our IITM facilities and good technical resource, we'll have a good establishment and we can achieve everything as possible.
My research is basically an interdisciplinary part where I combine both the contact mechanics as well as grasping, and this can be applied to both robotics as well as biomechanics field. Currently in robotics field, the most of the grasp contacts are conceptualized as points, so the basic fundamental contact of area and pressure is neglected. That we attack using our sensing system, which is available in IIT Madras.
If you feel you have a strong passion to
Thank you, Shivram, for the lovely video. There is a bit of a delay because of a technical glitch, but I still thank everyone being here, and a very good evening and a warm welcome to everyone. We are super excited to present today's webinar under this IRIS webinar series, Smart Marine Technology. So this research initiative under the Smart Marine Technology project is led by Professor Murali. Professor Murali is head of the Department of Ocean Engineering and also professor in charge, uh, National Technology Center for Port Waterways and Coast, NTCPWC, IIT Madras. He received the PhD degree in hydrodynamics of floating breakwaters in 1997 from IIT Madras. His research focus areas are coastal and ocean hydrodynamics, sediment transport, dredging, multi-phase flows, simulations, and general free surface flows. So joining Professor Murli as the speaker of today's program, we have Dr. S.A. Sasini Raj and Professor Gunter joined as the panelists. And unfortunately, due to some technical glitches, Professor Holden Lee was unable to join with us, and he would be the moderator. Hence, I would request Professor Gunter to moderate this session. So Professor Günther is the head of Department on Geo Risk and Civil Security at the Earth Observation Center of the German Aerospace Center DLR. He graduated in geodesy in 1984 and received the PhD degree in photogrammetry and remote sensing in 1992, both from Technical University Munich. His main research fields are satellite-based Earth observation and its application in environmental monitoring, emergency response and disaster risk assessment, and as well as development of early warning systems for natural hazards. And while coming to Dr. S.A. Sanasi Raj is the professor and Department of at the Department of Ocean Engineering, IIT Madras. His area of specialization includes wave hydrodynamics, wind wave modeling, numerical simulation of non-linear wave structure interaction, and coastal erosion and protection. So it's my pleasure to invite you all to this session, Professor. So let's hear about the center, which actually aims at developing a comprehensive framework of digitalization technologies and their application to maritime industry through smart and innovative solutions. Over to you, Dr. Gunther. Maybe you can request Professor Murali to start.
Gunter, please go ahead. You are muted, Gunter.
Yes, yes. Yeah, I'm sorry, I did not get, there was some interruption. Well, I'm of course very interested to cooperate with this institute, and also very interested in the work that you are doing. It's very fascinating. I saw the introductory video, and so I'm very interested to cooperate. I mean, from my point of view, I could bring in some experience what we are doing in Europe. I mean, in Europe, we have a very big Earth observation program, that is the Copernicus program. The Copernicus program provides free of charge data from the Sentinel series of satellites. And it also provides products and services. So there are Copernicus services in the marine domain, which can be accessed and can be used. So this is an offer that we can offer here from the European Earth observation program Copernicus. And another activity where we are involved is the International Charter on Space and Major Disasters. So in case there are, for instance, floodings, this is a mechanism which provides very fast satellite data in order to do the damage assessment and to evaluate the flooded areas. So this is a bit my background. And as I said, I'm very interested to cooperate with the center.
Okay. Shall I start, Professor Gunter?
Yes, please.
Yeah, great. Let me share my screen. Yeah. Are you all able to see my screen?
Yes,
Yes.
Professor.
Is my audio clear?
Yes.
Yes. Full clear,
Okay.
Professor. You can go ahead.
Yeah. Yeah. So, good evening once again, and good morning and good afternoon, depending on wherever you are. I'm very happy today to take you through our initiative at IIT Madras on smart maritime technology. This is coming out of an effort from IIT Madras to the Ministry of Shipping or Ministry of Port Shipping and Waterways presently, wherein we got this center NTCPWC funded. And as we worked through the years at NTCPWC, we had generated quite a few technologies which will be useful for the marine and maritime industry. And in this particular effort of SMATE, we are trying to further this effort in order to go to the next steps of commercialization, improvisation, commercialization, and coming to state of the art. In fact, we dream to become the leaders or one of the leaders in this particular field in the future. So the effort is led by myself, Murali, and my colleague Professor Sanna Siraj and Professor Dr. Kumaran Raju, who is working with us as a principal scientist at NTCPWC. Let me take you through a couple of slides to see what we have been going through and how things are happening. So basically, this effort of smart maritime technology or SMATE is to combine the efforts of scientific community from the various domains and through our student population and through our research efforts transform these efforts into meaningful technologies which can be used. Especially we're looking at the maritime industry. There are several challenges that the industry faces. Primarily the economical challenges, environmental and energy and functional challenges emanating from the age-old practices and also the regulatory requirements and also the requirements of the funding agencies. So there is a strong impact on their sustainability because of the various limitations that they have. So in this particular effort, we are trying to integrate the various technologies and develop the technologies wherever that they are required in order to provide smart solutions for various purposes. So that is the base, that is the main gist of the entire program. The special purpose information and communication technology applications and regulation based approaches play a vital role in setting up maritime facilities and smart ports. And therefore, new and innovative initiatives like this are required. And NTCPWC is in the right place and is playing a right role in order to lead this effort and to provide the various technologies which are required in the next 10 years of in the next 10 years to the industry, including major ports, minor ports, and also private and public ports, and to the entire maritime sector, including the related defense applications and the related aerospace applications. So therefore, NTCPWC envisages through the smart maritime technology effort to set up a center of excellence towards the next step of contributing at a global level through substantial research works in the areas of we have when formulating the proposal, we had divided this into 5 different work packages, starting from digitalization, smart sensing and communications, autonomous systems and robotics, intelligent navigation and advanced data analytics, and developing next generation smart ports. In India, we have a vision. We have created a vision for the next 10 years for the maritime segment of the overall development of the country, and therefore this will feed into the vision 2030 that the country has developed. So that's the overall objective of the program. The vision is to fulfill smart maritime technology, maritime requirements, and to address the transition process of the country. In this, NTCPWC will provide models, methods, and tools for improved design, assessment, and validation of innovative technologies and solutions to the industry. We are aiming at developing a comprehensive framework for digitalization technologies and their applications to maritime industry through smart and innovative solutions, including academic and indigenous scientific solutions. As I said, the work packages are five, starting from maritime digitalization and up to next creation of next generation smart ports and navigation. In the first work package, we want to create the base for the smart maritime technology. So therefore, we are focusing on digitalization. In the digitalization provides a contemporary opportunity to rethink, reconfigure, and optimize current business processes in the port sector, either operating the vessels or operating the cargo and the related logistics, or entry and exit of the various stakeholders into the port area and into the maritime domain. So that is the fundamental objective of the maritime digitalization. Maritime transportation also typically involves multiple actors. As I said, the stakeholders, terminal operators, and other port services, as well as the people who are operating the vessels and providing different types of infrastructure for their immediate collaboration partners. So, therefore, digitalization is a key asset across the common infrastructure, and creates the foundation for higher predictability and therefore higher efficiency and productivity. Therefore, this includes interorganizational re-engineering by moving operations and decision making between different actors into the digital domain, thereby bringing in efficiency and transparency, and also innovation by learning through the data that is available in this process, using AI, ML, and big data techniques to improvise continuously and to be able to perform in the next generation also. Coming to autonomous in the work package 2, it relates to autonomous vessels and robotics. Are you able to see the screen?
Yes.
Yeah. In this, over the last couple of years, we had already developed a few solutions. On the left, you can see a solar powered boat, which is an autonomous boat, which can operate autonomously in a predetermined port environment, and having deployed, it can perform its tasks and come back to the origin or its station autonomously. And it has been equipped with several sensors to aid the maritime industry. The 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 the, the solution that has been developed under this involves either completely solar powered technology or hybridized power technology in order to propel the vessel autonomously through its mission, and until it comes back to the host station. So therefore, this is one of the main component, or the motivating component of this particular work package too. And we want to improvise this in order to have cooperative autonomous vessels, wherein the vessels will operate, multiple vessels can operate in a cooperative manner in order to perform different tasks, either in the port environment or in the open water environment. This is our end aim, and this is achieved, I mean this, so therefore in this particular work package, we want to achieve the task of developing the technologies which which are involved in doing this exercise in terms of power generation, management of power, controlling the autonomous vessels, controlling the coordination between the autonomous vessels, and also sensor and also tasks like proximity identification, proximity avoidance, and route planning, and independent route assessment, and route augmentation processes. So therefore, the autonomous systems will provide a design will provide operational independency and possible which will help us possibly to deploy at all depths and for all climatic conditions, and will be able to make on the fly decisions with no direct human interventions and human control. So this program therefore will be able to feed into the maritime operations as a new segment which will automate and make the whole operations, the supporting operations of the port and maritime industry as a as an autonomous activity without the human interventions. The third work package is aiming at advanced ocean analytics, AML, and big data technologies. The current research challenges and trends tied to the integration, management, analysis, and visualization of objects moving at sea in different weather conditions and different environmental limitations, which are particularly critical in maritime operation, where online tracking, early recognition of events, and real-time forecast of anticipated trajectories of vessels and their operations, either inside the port or outside the port, shall be taken care of. So, therefore, the, the work package aims to integrate the entire operations of the maritime industry in a smooth manner and continue to improve and improvise the operations and improve the efficiency. Therefore, the objective is to employ IoT, Internet of Things, and the IoT sensors, AI, ML, and big data for precise maritime forecasting in terms of operations, in terms of vessel movements, in terms of environmental predictions, and integrate everything in a decision support system. That is the objective of this particular work package. Uh, the fourth work package is aimed at smart sensing, including involving IoT and communications. You can see an integrated middleware module which has been developed at NTC PwC for vessel operations in the port environment, wherein the ship sensors and instruments are placed on the left, and they provide different inputs, and then the ship middleware effectively is integrated into those sensors, and they can feed into the operation of the vessels either in the berth or out of the berth. So therefore, the advanced IoT based marine environment sensing will be designed to control different objects with the different objectives through the devices or equipment within the monitored marine environment in order to adjust some or certain physical and chemical parameters so as to improve the maritime environment, safety, and also the operations. The design, development, and deployment of an IoT based marine environment monitoring and protection system, therefore, is needed to address some critical issues including autonomy, adaptability, scalability, simplicity, and the improvement of performance and efficiency. Coming to the mission, the Vision 2030, the Maritime Vision 2030, which has been created in India. We even aim at operationalizing the entire navigational areas of the vessels inside the port area and outside the port area using IoT sensors, therefore bringing in highest level of safety and also highest level of transparency into the whole operations. Coming to the fifth work package, looking so therefore starting from work package 1 to 5, we want to get into next generation smart ports and navigation by means of employing digital twins, where we can create a digital twins on the computational and visualization platforms in order to continuously study and improve the maritime operations, and also, as I said, provide e-navigation in the approach channel and in the port areas, and also where the other stakeholders are involved, for example the dredging operations, the defense operations, and including the fishermen operations. All these could be integrated into the e-navigation system. So therefore, the work package 5 aims at the end result of evaluating performance of the port operations, including e-navigation uh, in the overall objective. objective. So therefore, coming to the deliverables, the main aim is to promote multidisciplinary high impact research through the Smart Maritime Technology Program. We not only are looking at generation of the technology, but we are looking at collaborative high impact research through generation of publications and generation of intellectual property, and further the current research wherever there is potential for improvement of the technology. The research works that are proposed are of globally competitive and of globally relevant to the current time that we are living in, and therefore it offers significant contribution to maritime technology and the maritime industry. The recent research publications are aimed at a high impact fora such as journals and also relevant conference meetings. The second visible output will be to address the industry sector where there is a gap in awareness of state of the art technologies and its applications. This will be addressed through tailor made workshops, training programs, webinars, and technology transfer meetings, and also newsletters and reports. The third output is aimed in developing commercial patents, as I said earlier, since most of the solutions are soft and hard products, and they should eventually be commercialized by our collaborators either in India or abroad. This also, I mean, the effort also aims at developing high quality manpower resources in developing and operating these systems. As the systems are getting developed, the industry will be requiring such manpower, and therefore we will involved in manpower development as one of the main activity. The program will promote international exchange programs with the collaborating universities. Currently, there are active international exchange programs through Erasmus Mundus program, and this will be strengthened through the common areas of academic and research interest. Online teaching programs similar to BSc in data science, which has been initiated at IIT Madras, will be introduced on digital marine and maritime systems. The courses will be devised to cater to the industry practitioners, seafarers, port engineers, and decision makers. This will be one of our key deliverable in terms of manpower development. Uh, as we can see that because the technologies will be relevant and state of the art, we do see that there is a lot of opportunity for commercialization, and through the commercialization we would like to sustain this particular activity of NTCPWC into the next levels, and therefore it will be a continuously sustaining activity, not only through funding from external agencies, and also through commercialization of our products and ideas. So therefore that is our endeavor to make this a success with the help of my colleagues, uh, our administrators, and friends and colleagues such as Professor Gunther Stuns, and also other colleagues around the globe. Therefore, this we hope that this will become an activity of successful and sustaining nature. Thank you very much. Hope I was on time.
Yes, Doctor. Professor Gunta, you can just kind of moderate the session. You can collect the questions from the question and answer, and then you can sort of make the session more interactive.
Um, I don't know. Do we still have time to answer questions?
We can maybe take one or two questions. I can answer them offline if there are more questions.
Yeah. So there are several questions in the Q&A. So maybe I would like to ask the audience just to raise their hand and pose the question directly now, and we can try to answer the other questions afterwards after the webinar.
Professor, I mean, the question and answer has already been posted in the question and answer section the Zoom platform. You can just read out the question, and then you can just you can kind of collate, and you can just understand which question is very important and which is necessary, and you can ask the same to the Professor Murli or Professor Sanasi Raj, so that they can answer
Rudra, in order to
it
save, yeah,
properly.
please go ahead, Gunther.
Yeah, so I take one of the questions from Dr. Mutusami. He was asking, respected professor, so it's a question to you, Professor Morali. Threat in future at ocean are climate change, global warming, and causing sea levels to rise, and so on. How can we monitor or reduce it in the upcoming technology? Could you provide some suggestions?
Um, I understood the question partly. See, the one of the main objective of developing the smart sensing technologies is to also monitor the ocean environment and the parameters of the ocean continuously without human intervention in a sustainable manner. So therefore, we do believe that even with the climate change effects, that these sensing, these autonomous systems and the sensing methods and elements will be able to provide continuous inputs and knowledge about the changing environment. Therefore, they will be very critical to that application.
Mhm, mhm. Thank you, Professor Morali. There is another question. I'm just selecting a further question. There's a question from Shashwat Pandey. He says, as a computer scientist, what is the major role of computer science in marine technology development?
In terms of technology development as a computer science, there are two main roles that we see. One is development of the middleware, where we need to integrate the systems into the software. So therefore, that is a very key role where the computer science scientists are involved. We do have quite a few computer science professionals working with us. The second area is AI ML techniques and development of the algorithms. We do see that there will be a lot of challenges in adapting the existing algorithms into the marine data and for the purpose of for the purposes of marine operations. So therefore, there will be a lot of opportunity for the computer graduates or computer science professionals to work with this particular data to develop these new algorithms and techniques.
Yeah. Thank you very much. And especially the artificial intelligence techniques and methodologies of machine learning and dealing with big data is a very challenging task and a very promising activity here.
Sure.
I'm selecting another question. How can, let me just, yeah, here's another question from Animesh Srivatsava. Can electricity generation also be a part of ocean technology? If yes, can you please explain its implementation on a larger scale? Or would it be a disaster to merge both the departments together? So electricity generation
Yes.
with ocean technology.
Yeah, the ocean technology is a very, I mean, plays a very critical role in electricity generation using renewables like a wave, current, and offshore wind. So that is one key area. The second area is utilization of the energy in the maritime sector. So that will be a very key area where our technologies also can help either to reduce or optimize the energy consumption.
Yeah. And there are two questions with respect to solar energy. So do, for instance, solar powered ships have a backup for night journey?
They do. They do. Either they. I mean, they plan to have either a backup or a hybridization using by combining solar power with another type of power, either wind or diesel power. So therefore, either a backup. A backup is a very unlikely situation because a large backup involves a large amount of storage space wasted for keeping the backup systems, including batteries. So therefore, what is most likely to happen is to have hybrid power in case nighttime applications are required. This is most likely to happen. In our case, for example, we had designed the system for 6 hours of operation, but then with additional storage on board, we will be able to extend it to 10 hours or 12 hours. So this is something that is still in ongoing research, and these are the two directions in which it is going.
Mhm, mhm. Thank you very much. I'm taking another question. I'm shortening it a bit. It's about the disasters. So he's telling he's watching a documentary about the risk of oil leakage from sunk ships. So how much time is left before that catastrophe, and what measures should be taken? And as sea level is rising and cyclones are very common these days on various coasts, this seems alarming. So again, also talking about these disasters. So oil leakage and disasters like cyclones.
Thank you. It's a very generic question, so I would like to provide a very generic response. Um, the smart sensors and the smart applications that is being developed in this effort definitely will be helpful in monitoring the disastrous situations more closely and provide earlier responses. So therefore, they will be a very, I mean, we will play a very critical role in monitoring and responding to those disaster situations. Thank you.
Yeah, and just to add to that, for this topic, Earth observation can really contribute because we can monitor these things. So we can monitor these oil, for instance, we're using radar images. We can also monitor the disasters affected areas and so on. So this is also a contribution from Earth observation. And you in India have a very strong space agency, ISRO, with a large fleet of satellites. So this can be used very effectively. Yeah.
Sure. Thank you.
Um, Another question is, he says, a very interesting presentation and welcoming initiatives by NTCB WC. And the question is there any research taking place at this center in terms of optimizing the capital and maintenance stretching at ports for more sustainability and beneficial use of dredged material in the ports and harbors and also inland waterways?
My answer is yes, and we had provided several recommendations to the ports and the ministry, and they are under examination. For the information of the audience, we have also done several projects wherein the dredging efforts are optimized, either by minimizing the quantities or by cost or the cost. So therefore, for both the questions, my answer is yes, and this is happening in an advanced level at the center.
Mhm. Thank you. There's a further question dealing again with his energy supply. So he says instead of solar energy for fuel, we can also use hydrogen fuel um, because plenty of water is available, which can be used for hydrogen fuel. Can you comment on that?
No, this is an area we see. The solar energy area is an area that is a little bit matured, and we have adapted the technology to. I mean, our expertise is on the controls and also in designing the vessels. So we have adapted the solar energy technology to our requirement. However, in terms of hydrogen energy, when the technology is at sufficiently advanced level, we will definitely consider those options also.
Mhm. Thank you. Another question is talking about material science. Has it any role in maritime technology?
Uh, yes, in creating smart sensors, the material technology is definitely having a role. But and also in day-to-day operations of the vessels and various maritime platforms, in terms of minimizing the fuel usage, etc., there is a lot of applications. So those are two areas where even IIT Madras is looking at the material science aspects into marine technology.
And just add on to it, because many of them are asked about civil engineering role, engineer role here, mechanical engineering, industrial engineering. so including the material science. And of course, this is a multidisciplinary, and I can say interdisciplinary also. And any engineering background, and not only engineering, science background also, because understanding the basic cyclone, tsunami, etc. is ocean science. People, they come into the picture, so they play a major role. And so it's our group has the expertise in vast disciplines, civil, mechanical, and computer science, so even computer science, and so many applications. So without which, so working together, we of different disciplines, we cannot win the game. So this is a thing. And then one just thing adding to the remote sensing. So most of the time, remote sensing technology, we greatly adopt in the ocean technology. See, optimal ship routing. So one of the $1 million industry. Say they consistently take the data from remote sensing, then they integrate and give the optimal ship routing. So remote sensing is part of the game in the ocean technology, particularly when we are talking about smart bird into the system. So we have to act everything live or up to date. Okay. Okay, proceed. Yes.
Thank you.
Thank you very much. So I'm just looking at the question. I think we have at least answered most of the questions. I mean, the remaining questions we could answer after the session in written form. So if there are no more urgent questions, I think we are already above time. So
That's right.
Yes,
Uh,
perfect.
when I would say from my side, we could close the webinar if there are
okay.
no more comments from your side.
Rudra, I would request you to collect all the questions and send to us by email. We will provide the responses, then you can send to all the participants.
Sure, Professor Murli. Ms. Ujjwala, we can do it, right?
Sure,
Yes,
Rudra.
collecting all the, yeah.
Yes,
So,
we have the same
so
thing.
before, thank you, Ms. Before closing the webinar, would you like to give any closing remarks, Professor Murli, Professor
Yeah,
Sanasiraj, and Professor
I would
Gunta?
like I
And
would
that
like
would be
Professor
great
Sanas
if
Raj.
you could closing remark.
I would like Professor Sanas Raj to give the closing remarks. Sanas Raj, please.
Okay. Okay. So, so this is an upcoming field, and in fact, where we work in isolation before 2000, the last 2 decades has seen vast, say, like last decade was the data world. We were in the data world. We are not underutilizing the data. And in fact, after remote sensing has come into the picture, lot of data are there. We are underutilizing it. Now, because of all the other techniques like AI and machine learning and other perspective, we are trying to integrate data, or we are trying to utilize the data in a much better manner. So this is in many perspectives. So this is another one we are supplementing with the remote vessels, where we are complementing it and we are utilizing it. So this smart technology has been a great tool. We are trying to utilize all our knowledge, prior knowledge, data that have been collecting, and that's also being collected through the satellite and different other means to a very useful manner to the users. Say fishing, actually in India, we are giving current up to date the fishing zones to the fishermen lively. Even after they take off the boat, it's going to them lively. So all these things are possible only using this smart technology, and also using a simple mobile phone. We can do a lot of wonders with the background the technology available, which includes the software, hardware, and all the knowledge of. So, Professor Gunther, would you like to add?
No, nothing to add. You explained it very well. Yeah, nothing to add from my side.
Okay.
I wish to thank everyone who has participated,
Okay.
and also I wish to
Okay. I'm
thank
back.
Professor Gunther students. Thank you very much.
You're
Thank you
welcome.
IOA
Thank
team
you
for
as well.
coordinating.
Thank you, everyone. And I mean, I should mention my special thanks to Professor Gunta for wonderfully moderating this session. I mean, which the request was made at the last moment. Needless to say, it was a very good session, Dr. Murli, and thank you very much for your closing remarks, Dr. Sani Siraj, and thanks for the participation from the audience. And we are looking forward to meet you in the next webinar. Thank you once again.